right, welcome guys to college algebra. We're going to do some story problems. We're going to kind of create a format so that we can get all of the answers in one spot. And then that way, when you're doing questions or quizzes or on any test, you at least have a starting point and you can at least get some of those answers answered. Um, in college algebra, we're going to be talking about all different types of graphs. We're starting off with linear. Linear is what you used in Algebra 1. Just as a reminder, it was your y equals mx plus b, where m was the slope and b was your y-intercept. That's really what they should have hammered into you at that time. When it comes to story problems, B is going to turn into like a fixed cost. It's going to be something that we have to pay no matter what. It won't go up and down, but it's kind of like an initial, you have to pay this. And your slope or rate of change, he's going to be more of the variable cost. He's the one, he's right next to the X. So he's going to go up and down. So based on how many tickets you buy or how far you've gone, all of that stuff is going to be the slope. So again, we're going to start by doing these linear equations, so we're going to be focusing on that equation. Before we do, we're going to want to make sure that we can graph all these functions that we're going to be doing. I want to talk to you guys real quick about the difference between your discrete graph and your continuous graph. So looking at it visually, it's super easy. Discrete graphs are the ones with dots. They do not connect. You have just dots on the graph. So those are a clear indication that you're working with a discrete graph. A continuous graph will actually connect the dots. You'll have a line. Now, even though it says continuous, it doesn't mean that it goes on forever. Like this one up above, we have a starting, we have a stopping point, but we are connecting the dots. That's what actually makes it continuous. When we're talking about story problems, it gets a little kind of trickier. What you want to do is you want to think of the domain or your x values, and you want to ask yourself, in the story problem, can I have a half? So for instance, can I have 2.5? Does it exist? If I look at it, and let's say we're talking about people, so x is going to represent the people, well, I can't have 2.5 people. I either have 2 people or 3 people. I can't have half a person. That won't exist. So that would be a good definition of a discrete situation. Continuous is, again, if we look at that 2.5, can I have weight? Can I have 2.5 pounds? Well, yeah, I can have all types of pounds. I can have 2.5, I can 2.25. There's all different types of weight I can either weigh or I can be picking up. So weight would be considered discrete, or sorry, continuous. So it's really about that domain, and you got to ask yourself, can you have that? That will determine the graph. Everything that you graph on Desmos is going to look continuous. That doesn't mean it is. So you have to be the one that says, even though you connected that Desmos, it's not supposed to be connected. So you have to do it based on the story. All right, let's get into that format. So as you can see, I have A, B, C, D, E, and F. You don't have to go in that order. So don't think that just because I have A, I have to start with A and then go B and then C. You're going to see that I will jump around. I'll usually start with A with linears, then I jump to equations, and then you'll see me jumping over here to drawing the graph and the table. So just know that they don't go in that order. There are things that you want to write. So when we define variables with linears, you guys are very comfortable with X and Y. I want you still write those, that way we know what they are, but I want you to put that the X represents our input values and that they're also our domain. So when we look at the X, that's our input and our domain. Our Y's are our output, and they're going to be our range. So we'll write that up there. After we write that up there, based on the story problem, we're going to write the functional notation of these things. So for me, when I look at this, our basic function notation is f of x. Remember that when we're talking about y, if you have the two variables, f of x is the same thing as y. It's just written differently. The letter that's inside the parentheses, that will be the domain. So when you're doing this, just keep that in mind when you're looking at stuff, that that's your x, whatever's inside the parentheses, and the one that has two letters is going to be the range. We kind of already talked about it, but all of these story problems are going to start off in their linear format.
We can move this around. You're going to see that we're going to change this up so that the equation matches the story problem. Don't be fooled. You can also write it like this, where you switch the mx and the b, but keep in mind that m should always be next to x, or he should be next to your domain, your input value, and b should not have a value next to it. It's kind of a starting point. Your work is basically explanatory. A lot of the time, because we get to use calculators to plug things in, it's basically just showing what you do if you have it plugged in. Your answer is going to be whatever you get, like t equals 5. And your complete sentence, you just need to make sure you have the unit measurements. And I'm going to show you, the sentence can vary a little, but as long as you have those components, I'll show you what part when we do a problem that's really important. Remember, when it comes to the graph and the table here, for the most part, you're going to see that we hang out in what we call quadrant 1, where everybody's positive. So your x value is positive and your f of x value is positive. Basically, we're going up and we're going to the right. Negatives usually in story problems don't exist, so we'll kind of ignore those areas that will play a role. And then we'll use a table. Now, we will use Desmos to do most of this calculation, all right? So this is going to be our x, this is going to be our f of x, and we want to start using the terminology input and output because we're actually in upper level math now, all right? So we don't really say x and y, we say input value or domain, and we'll say output value or range. All right, let's jump to that example. We have 2 examples to go through, and then you guys can practice on your own. All right, so Diana decides to go to the fair. There's a $50 entrance fee and a $5 per ticket. So I know those are going to be numbers I'm going to use in my equation. I need to write an equation to represent the situation and then find out Diana's total cost. And then it gives me this. That's actually very important. What that means is I don't get to choose my variables. They're given to me, right, in this scenario. And then it continued on, what would she get if she bought that? But I want to kind of highlight that because we want to make sure we know that. So I'm going to start off. Let's say I'm totally lost. I can at least get A down. A is going to be the X. I'm going to write down the stuff that needs to be, and the Y. Sorry, so I'm going to go X here, and I'm going to say that's my input values. This I'll always put down. It also is my domain. I want to write that down. The Y is going to be the output or the range. That way, when they ask me what is the output, what is the range, I can literally just say it's this value or that value. The part that switches is this. So CT. I can see that that's using 2 letters, the C and the T. 2 letters means I'm talking about the output. So I'm going to go ahead and put C of T. So my Y value and C of T are the same thing. And I know that C of T is the total cost because it says Diana's total cost. And then it gave me this. So that's this, and it also represents total cost. So I'll put that down there. This, the red, will change based on the story problem. Inside the parentheses is the T, so that must be my input value. That's what I'm going to plug in every single time. And then again, I have to look up here and say, okay, well, what would the T represent? And I'm going to kind of get that if she buys 120, oh, look, tickets. So T must represent the tickets. How many tickets she's buying, I'll plug that in, and then it'll give me my total cost. That's how I'm going to write this equation. All right, I am going to now jump to the equation. So I'm going to skip B because I can't plug in nothing into Desmos, and I'm going to have Desmos do most of the heavy lifting down here. I'm not going to really be graphing this all on my own. So I know that we're talking about linear, so I'm talking about this wonderful equation that you've used 1,000 times, hopefully by now. I know each one of these letters has to change, so I'm going to come over here and say, okay, well, the Y, and I look here and go, oh, well, I already had Y, and we said he's CT, so I'll go ahead and put C of T here. And then I know X was right here, and we said his variable will actually be T. So wherever I see X, I'll put T, wherever I see Y, I'll put CT, and these other 2, the rate of change and the y-intercept, that's up here in the story problem. So when I read this, I like to start with B. That's my fixed cost. If I don't buy a single ticket, not one single ticket, what will it still cost me to go into this fair? So when I look at this, I go, oh, it's going to cost me $50 just to enter. No matter what, it's going to cost me $50. So that's a positive 50. I'm going to have to add 50 every time. The $5 per ticket represents our rate of change. So if I buy one ticket, the total cost will be $55. If I buy two tickets, that's an extra $10. If I buy three tickets, that's an extra $15. So this per, whenever you see this, is a good indication that's probably your rate of change area, and you can put that in there. All right, this is the equation. So if they ever ask me, what's the equation for the situation? That's this first part. That's right here. That's this guy. He's also what I'm going to use when I go to Desmos. So now I'm going to use Desmos, and I got to get the graph and the t-chart. So I'm going to come over here. Now remember, you can't put t. Desmos doesn't read a story problem and know what it's saying. I'm going to go back to the x and y so that Desmos will graph it. So 5x plus 50. And I can see off on the left-hand side my graph somewhere over here, and I don't want to be in these negatives. So I'm going to zoom out so I can actually see my graph and say, oh, here's the positive. Notice I'm grabbing it. I don't care about negatives. I can't have negative tickets, and I can't have negative cost. So this is it. I'm going to click on the graph and try to find, there it is, where the zero is at. So he's starting at 50. So when I go over here, I'm going to start drawing my graph. Once again, I know it's positive money, and I know it's positive tickets. So I'm going to stay in this one, and I know I'm going to start at 50 on here. I better label my graph first. Sorry about that. This is going to be total cost. That's what the Y represents. Sorry, I have to write sideways. It's kind of hard. So that's our CT. This is our T, and this represents how many tickets I can buy. So those things we should do before we get to Desmos. Sorry about jumping. All right, I said we started at 50, so I'm going to go ahead and make a heartbeat. A heartbeat means I'm skipping numbers here. I don't want to start at 0, 1, 2, 3. I'm going to jump, and I'm going to jump because I know it's a positive slope. When I look at this graph, it's heading up. So I'm going to start at 50. So I'm going to come here and go right here. That's 50, and he's my starting point. All right, I'm going to go back to Desmos, and I'm going to get the table of values. So I'm going to go up here to this little edit list, and you can see that little table. I'm going to click on it, and notice it gives me a table of values, which is awesome. I don't want these negative numbers. They don't exist. So I shouldn't have any negative numbers. So I'm using 0, 1, and 2, and that gives me 50, 55, and 60, and that'll be the table that I use. So I can come over here. I can start by going, this is T, my input. This is CT. That's my output. And as I said, we started at 0, and it went 1, 2 on the table in Desmos. 0 starts at 50, then it goes 55 for a total cost, and then it goes to 60. And this table can go on and on and on based on how many tickets. And she can buy as many tickets as she wants, so it will go on forever. All right? And I'm going to plot these points, 155 and 260. So I'm going to come here, I'm going to go, okay, well, here's 1, here's 2. I don't really need 3. I got 50, and we'll just go by 5s, 55, 60, 65, so we can go by 5s here, because it's going by 5s here. So that's 55, that's 60, that's 65, and the cost can go up and up and up forever. So I'm going to go 1 is 55, 2 is 60. Now at this point, I do want to ask myself if I want to connect the dots like they do in Desmos, or do I want to keep them as dots? So this is where I have to make that decision. And what I'm going to do is I'm going to ask myself, can I purchase half of a ticket? No. I have to either purchase 1 ticket or 2 tickets. They're not going to allow me to purchase half of a ticket. So in this case, I'm going to leave them as dots. So Desmos shows it connected. It is not connected. This is a discrete graph, and I'm going to keep it that way. All right, so that kind of gets these parts already. Now the second half of this question asked us to calculate. So we're going to use Desmos to do the calculation. In our work area, all you really have to do is show that you know what you have to remove and what you have to plug in. So in this case, I have the tickets. I have 120 tickets, so I'm going to remove the T's. So I have a T right here with CT, and I have a T right here by 5, and I'm going to replace those T with 120. And I'm going to come over here and put 120. This is just fancy. It's part of my answer, So I'm just going to come down here and go C of 120. That's just functional notation. We just keep it there. But this half, this other side of the equation, this is what I'm going to plug into Desmos and have him do the work. So I'm jumping over. I'm going to just add another line. Or you can actually come in here and type in 120, just so you know on the table. And it's going to give you an answer. If you do it on the table, it says it right here. You can come in here and just replace the x with 120, and you should get 650. So I'm going to come here and say, okay, well, I got 650. Last thing I want to do is write a sentence. This tells us that you understand what the word problem was all about the whole time. So the first person is Diana. I'm definitely going to reference her. So if Diana buys 120 tickets, I want to talk about the domain. So that was the 120. She will have to pay $650. I'll write that. And I know I'm going to go out. Sorry. Oh, I made it. Yay. All right. So she'll have to pay $650. The important part that we look at when it comes to a story problem in math is that you are addressing the input, the 120, and I put time, and that should say tickets. Let's replace that. That you're using the right. See, this would be where I get marked wrong. I want to switch that to tickets. Sorry. So I'm looking for the 120 and that you have that input with tickets and that the 650 represents a dollar amount. That's your output. That was our total cost. So cost is dollars, input was tickets, and I want to make sure that those in the story problem are represented. You might have a different sentence, and that's fine as long as 120 is with tickets and 650 is with the dollars. All right, let's jump to another one, our last one before you guys are kind of on your own that we will do. I'll try to go with it quickly or as quickly as I can. Emmanuel is driving to LA. He knows that it's roughly 400 miles. So he's starting off 400 miles away from LA. He's going to drive at 70 miles per hour heading to LA. So what I know is these miles should be going down. If he's starting at 400, I should be heading down. And he should be getting less and less the closer he gets to LA. I'm going to write an equation. Again, I do not have a choice. They've given me dt. That means I have to use those variables. And I can already say if they're talking about dt, that's distance, that's right in front. For a certain amount of time, t must be time. So we're going to reuse that t variable in a different way. All right, I'm going to come up here and do the easy part, x. We know that's our input. We always write this down. We also know that that is also our domain. We know that the y is our output, and it's our range. I want to have those things written down so I know what they are. Now I'm going to actually look at the story problem and get the rest of this. So I look up here, that highlighted thing is my other letters. That has 2, the D and the T, so that must be, again, the range, because they always come with 2 letters. And he represents distance. So according to the story problem, this is the definition. P is inside the parentheses. He is our input, and he represents time. Right? And I know that this distance should be going down. Again, I also know if I want to start in this area this time, that I have to have a positive distance and I have to have a positive time. I can't go back in time and I cannot go into negative distance. So those parts of my graph, they will not exist. I'm going to go ahead and label my graph. dt, this side, the y, is actually distance. And I can come up here and put d parentheses t because that's the y. This is the t, and he represents time. I'm getting that all off that. I can also set up my table because I'm going to be getting one of those off there. Again, we want to use the terminology we use, so we know this should be our input. So if it asks you, what are the input values? I can just copy those down. This is going to be my output. Copy those down. And then I can also put the input is our t variables, and our output is the dt. So I have things set up for Desmos, but I haven't actually done the Desmos. So you can see there's no points or graphs or anything beyond this. So to do Desmos, I need to write an equation. In this case, because I know the distance is going to head down, we're going to start at 400 and then it should start heading down. I'm going to rearrange my y equals mx plus b. I'm going to put the b in front because it has to go down from there. And I know I'm going to subtract however many miles I am after however much distance I have. So I'm going to switch those. Again, if you flip this, yet you know in your head this distance should be going down, and it looks like it's going up, you know you've flipped your values the wrong way. So it's just something you, once you practice it, you kind of catch on to it. All right, the easy variables to change are the y and the x because they're right here, y and x. I'm going to switch those to dt, and I'm going to switch the x to a t. All right, I'm going to come here and put the negative sign. And then the two other numbers are, of course, going to be the two numbers in the story problem up above here. So I have 40 miles and 70 miles per hour. You see this? That's a good indication that's the guy that's going to be next to time. He's going to drive 70 miles for every hour. And then 400 is going to be our starting point. So we're starting at 400, and then we're taking away 70 miles every single time. All right, as I said, we know for a fact we're not going to have negatives, so I can go ahead and start with the first point will be at 0. But I'm going to go ahead and jump to Desmos now, because now I have my equation. As I said, I'm kind of going fast, but you can rewatch this. So 400 minus 70, and I'm going to say x because Desmos doesn't do story problems. So we'll go 400 minus 70x. And I can see I don't have my starting point. I'm all the way up here somewhere, so I can zoom out and trace it. We kind of already know. Hopefully some of you are like, Miss, you said we're starting at 400, so the graph should probably be at 400. And if you click on it, you'll see that the starting point 0 is at 400. I can move this point, but the point will be, oh, I should be able to, but it's having trouble. So that point right there is at 0, 400. And then I like to come down here for me and click on this one. This is where it's crossing the x, because again, I can't be in the negatives on any of these. So this guy has negative x values, this is negative on x and y, and this is negative on y. So these, I know for a fact, aren't going to exist because we're talking about miles and time. So I can't go back in time, can't have negative distance. So these are the points I'm going to graph on my graph. I got 0, 400, and then I have this almost to 6, 0. So on my graph, I don't have to make it look all crazy like Desmos. I can just go, what, 1, 2, 3, 4, 5, 6, and it looked like on Desmos it was really close to the bottom, right around here. So that's kind of where it ends, and then it goes into the negative land. I do want that heartbeat because I'm definitely going to be going kind of weird. I know I want to start up, so the very top one is going to be at 400 for sure. And it's a linear one. The question becomes if I want to connect it or not. So I got to ask, looking at my domain, it represents time. If we talk about time, can I have half a time? Well, yeah, I could be at 4.5, that's 4:30. I can have 4 and 10 minutes. I can have 4 and 1 minute. I can have 4 and 1 second. So that means that this line, I don't really need to graph all these dots because I know it's continuous, which means these should be connected. Sorry, my line isn't perfect. Actually, I guess I could have just used the drawing tool and that would have given me a perfect line. So just make sure you know if it's discrete or continuous because it'll make your life easier whether it's connected or not. I am still going to use it to get my t-chart. So I'm going to come here, I'm going to hit this, get my graph. I don't care about these negatives. It goes 0, 1, and 2, and it goes 330 and 260. So I'm going to go, okay, there's 1 and 2, and we have 330, 260, and it started at 400 because I graphed that point. So I got my graph. Anytime they ask me for this, I have that information, I'm good. Then I go back up here to answer the second part of this question, which was he's been driving for 4 hours. So I'm going to grab my equation. I'm going to rewrite it. This part, because you're using a calculator, this is all you really have to do is show me that you know that you have to replace, in this case, time, because it's given us 4 hours, with t. So I'll put in 4. Or if you end up having to replace the dt. So you need to know which variable, whether you're putting in for the input or the output, In this case, most of the time it's the input. This part is part of my answer. I don't need to worry about him. It's this other half that I will actually put into the calculator. So 400 minus 70 times 4. So I go over here, I just type in, grab this one, go 400 minus 70 after 4 hours. And I can see it gives me 120. I could have also put it in this graph, but 120. So I come over here and say 120. Notice I don't care what it is, I'm just giving the answer for E. F is our story problem, so I need to actually go back up here and kind of refresh my mind. Emmanuel, he's driving to LA, he starts at 400, I'm subtracting 70 miles every time, and it's been about 4 hours. So I want to say after, and again, everyone might be a little different on the story problems, how you start it. After 4 hours, Emmanuel will be 120 dt represented distance, so he'll be 120 miles from LA. So some of you might have said after 4 hours he still needs to go 120 miles, or there's all different ways that you can answer a story problem. They can be in your words. What I'm looking for is that you represented the 4 hours, your input, and you have the 120 miles, your output. So you need to make sure that you tell me and you have their units that represent what's in the story problem. Well, that pretty much concludes this. I hope it helps. Practice doing some of these and then answer the questions. You're going to see they're worded all over. Sometimes I want to know the answer of 120. Sometimes I'm going to give you a bunch of sentences and see which, if you can pick the right one. I'll ask you domain. I'll ask you range. I might ask you, is the graph discrete or continuous? I'm going to show you different ways that they ask these questions. But all of them, if you take the time to do this, you then just look up here and choose it. So I know this seems like you're kind of, don't jump in and just try to answer a question. First do this on a scratch piece of paper or on a whiteboard on something, then go back and answer the story problem. So we're starting off with linear, but please know that college algebra is about basically all of this. This is all college algebra is you're going to have a different graph. It might be a quad graph. You might have this. You have to identify input, output, domain, and range. And so practice on the linear, the easier ones, so when we get to the harder ones, the equations will get a little bit more challenging, but you're used to writing up all this and you should be good. All right, I'll be walking around. If you need any help, just raise your hand. I'll come help you.